Welcome to Specification 212 Drill Seeding Method. The video provides a concise overview of the drill seeding method used for successful vegetation establishment in highway construction projects. What is the drill seeding method? The drill seeding method is a technique used to mechanically plant seed directly into the soil. Drill seeding involves the use of specialized drill equipment that creates small holes in the soil, deposits the seed and amendments into those holes, and then covers the soil over with a roller or chains. This process helps ensure good seed-to-soil contact and improved seed spacing and coverage, which generally provides better germination and establishment than broadcast or hydroseeding. Drill seeding is a precise, efficient, and cost-effective method of planting seed. It can be completed in dry conditions, and unlike the hydraulic seeding method, it doesn't require water for the application. Drill seeding is followed up by final stabilization methods including mulch, crimp, and tackifier, hydromulching, or erosion control blankets. The audience for this video includes stormwater management plan designers and reviewers, region permanent stabilization subject matter experts, CDOT design engineers, and project design engineers and their designees. Refer to CDOT Specifications Section 207 and 212 and Design and Construction Bulletins before conducting drill seeding. Instructions and guidelines for Specifications 207 and 212 include specific details for subsoil and topsoil preparation, organic fertilizers, soil amendments, seeding methods, and checklists for inspectors. The first step is determining seed mixes and amendment rates. For instructions on how to do this, please watch Swamp Design Topsoil Testing Procedure video. Rates of topsoil amendments are determined in the design phase based on analytical results of the project's topsoil. If not testing site topsoils, then the rates are based on the standard rates in Specification 212. Use your region's standard seed mix for elevation and moisture, or work with the CDOT headquarters landscape architect for a site-specific seed mix and rate. Drill seeding is CDOT's preferred method of seeding and offers several advantages for highway construction projects including better seed-to-soil contact, as the seed is placed directly into the soil and is followed by mechanical soil coverage, which can increase the germination rate leading to increased plant establishment. In addition, drill seeding places the beneficial mycorrhizal fungi right next to the seed, aiding in revegetation success. Another advantage of drill seeding is its cost-effectiveness. Drill seeding can place seed and amendments uniformly in a relatively short amount of time. It is important to note that while drill seeding can offer many advantages for a highway construction project, it may not be the best option for every project. The specific requirements and constraints of each project should be considered when deciding whether or not to use this method of planting. There are a few potential disadvantages of using drill seeding for a highway construction project, like limited efficacy on steep slopes, hard-to-access areas, and rocky or clay soils. Drill seeding equipment cannot access steep slopes over 2.5 to 1. Drill seeding cannot be conducted in rocky soils due to potential to damage to the equipment. In clay soils, the equipment is unable to get the calibrated depth effectively. Due to cost of mobilization and access of equipment, drill seeding should be conducted on sites half-acre or greater and where there is sufficient space for equipment to access. Requires operator expertise for calibrating the equipment. Limited for wet and frozen soil conditions. Drill seeding should not occur when soils are wet or frozen. Working in wet soils leads to soil compaction. Drill seeding should not be conducted in wet soils, as the drills may not be able to penetrate the soil and the seed may not be deposited at the correct depth. In addition, the equipment will compact the soils. High winds. Seeding should never be conducted during high winds. It's important to note that although there are some disadvantages, these can be mitigated with proper planning, equipment, and execution of the project. For hard-to-access areas, rocky soils, and steep slopes, the hydraulic seeding method should be specified for installation. Construction phase. Drill seeding inspection and verification. Whether you are a reviewer or inspector, review the contractor's method statement, baseline schedule, and milestones for timing, equipment, and quantities of seed, and amendment and their storage needs. Application of organic fertilizer, soil amendments, and seeding should be milestones in the baseline schedule. The timing of seeding is crucial to the establishment of desired vegetation. It is important to seed during the seeding seasons in Section 212. After topsoil placement, seeding and final stabilization activities must occur within 4 days. Final stabilization, including straw crimp and tackifier, mulching or erosion control blanketing, must occur within 24 hours of drill seeding. Seed should match the species and rates shown on plans. If there are substitutions due to availability with suppliers, work with your region's permanent stabilization subject matter expert for approval of the substitutions. Inspection and verification. Refer to the construction manual for guidance and checklists to assist in review of seed. Amendments and the drill seeder calibration. As discussed in the Specification 207 Subsoil Preparation video, soil decompaction is a critical component in addition to topsoil preparation to ensure the success of drill seeding and resulting vegetation. Conduct a site inspection. The seed bed should be free of stones and other debris greater than 4 inches in diameter. Review the vendor's packing slip of seed. Confirm the seed has not been in possession of the contractor for greater than 30 days. Reject seed bags over 30 days old. The packing slip needs to include a copy of the purity and germination report dated within 13 months of date of seeding. Proper storage of seed and amendments. Seed and amendments are to be stored out of direct sunlight, surface water, and precipitation, and not in temperatures over 80 degrees that can destroy biotic life in the amendments or reduce the germination of seed. Reject wet, moldy, or damaged seed and amendment bags. Save in the project record, seed tags, submittals, and correspondence. Review application rates of amendments. Refer to the contract for quantities of organic fertilizer and topsoil amendments. Seed should match the species and rates shown on plans. Work with region permanent stabilization subject matter experts to help verify seed mix and rate, approve seed and amendment submittals, and answer any questions that may arise during construction. A seed tag calculation worksheet and seed and amendment quantities checklist are available on the Landscape Architecture website. Review 212 Drill Seeder Calibration video. Overall, the inspection and verification of drill seeding is crucial for ensuring that the equipment used for seeding are in good working order, that the seeding method is performed correctly, and that the seed and amendments are being applied at the correct rate. Maintain proper topsoil surface conditions per Section 207. The seed bed or topsoil surface should be left in an uneven condition with a surface variation of 2 to 4 inches. This helps prevent erosion, but also creates various microclimates to help with germination. Do not work in frozen or wet soils or during periods of high winds. Review application rates of amendments. Refer to the contract for quantities of organic fertilizer and topsoil amendments. Seed should match the species and rates shown on plans. Seeding rates should be as specified in the plans. With seeding, more is not better. Adding too much seed results in a vigorous initial establishment, but in the long term, there will be less vegetation due to the seedling's competition for sun, air, nutrients, and water resources. Underapplication of seed can lead to increased growth of weeds where surface soil is exposed, as well as increased potential for surface erosion. As discussed in the Specification 207 Subsoil Preparation video, soil decompaction is a critical component in addition to topsoil preparation to ensure the success of drill seeding and resulting revegetation. What does the engineer inspect and verify? The inspection and verification of drill seeding method is crucial for ensuring that the equipment used for the seeding process are calibrated and in good working order, that the seeding process is being performed correctly, and that the seed and amendments are being applied at the correct rate. Thank you for watching. Please watch our next video.